attending papari ron lut lut tonya.
Ini saja expert lagi. Apa sih?
alam sin chan hei lo ti mai no ne kaling ka
đây để kiểm cân tiền tổng lâm bằng gì
Hello, can you hear me? Cyrus.
oh hello sir te
yes sir I can hear you sir
minute ni ala oma kan eng lo kan la chan lo deu ni timing ka kan hak deu ri imo i thuan soi lai ka chon nang mai lo mute i lo in mute down chuan thuan soi lo lai khan i soi don huna khan in unmute down chuan beng seng lo sim to lo tur start don to kan mute ka chok lo to ni ka chong to minute khata lo kun lo atral to pe mini om la ka free deu in om sa ja til da lo ti to lo ni ai na kina ai la wa ilam o in mai don
Hello, good morning, and welcome to the state-level webinar on Basics of Statistical Packages for Social Sciences, SPSS. This webinar is initiative of the Department of Social Work in collaboration with IQSC Hatim College. Dear participants, today our panel is a consistence of eminent speakers to talk on the given topic. Without further ado, may I introduce Dr. Silal Exama, a well-known figure and a legendary identity in promoting social work education in Southern Mizoram, and a pioneer member of the establishment of the Department of Social Work Hatim back in 2010. At present, he is assistant professor in the Department of Social Work, Mizoram University. Also, we have Mr. RTC Lerumbrota, a young and dynamic scholar with plenty of contribution in the fields of research and statistics. He is our very own alumni, and we're glad to have him back among us as teaching faculty in the Department of Social Work here in Hatim. Welcome, Dr. Tea and Sir RTC. With this, may I now invite our Honorable Principal, Mr. Wonsama Vansong, for a welcome speech.
Good morning, everyone. Ladies and gentlemen, at the very outset, I'd like to bring greetings to Mr. Chairman and Coordinator, distinguished guests and resource persons, my colleagues and dear students. I indeed deem it a great honor to deliver a welcome and opening speech for our webinar on the basics of SPSS. In making this webinar such a resounding success, I hope that everyone is going to contribute in a great contributions. So I'd like to congratulate, and I do really appreciate indeed the hard works of the Department of Social Work and the IQSC for starting to realize our dreams in making learning possible through various means that we have at hand, and even gathering resources that we did not already have. Now, ladies and gentlemen, let us remember that we're entering into the third decade of the 21st century by now, and that our learning systems and styles have to be based on creativity, innovations, and new findings. In order to make that happen, we cannot miss out the necessity of research in our learning systems. We are a young generation, and we need to cope with trending changes in the world. Imaginations bring about ideas, and they need to be supported by facts and figures. Ideas alone are only dreams unless they are realized with actions. Actions cannot be really very strong and effective unless they are supported by facts and figures. So research works cannot be belittled at this time in this century, as we are taking up our studies in various departments and disciplines, under various disciplines, especially for the social sciences. Research is very important, that even a college student, and not only a college student, right from the graduation from the school, a student needs to be engaged in various kinds and various types and levels of research works. So in order to bring that successfully and to make it very effective, we need to learn the importance of the techniques of research. So this SPSS is a very important and a very useful tool, very friendly, user-friendly, and very easy to understand tool for research works, especially for the social sciences. And we are going to learn about that. And I'd like to introduce afresh, although our chairman has already introduced, our resource persons for today. Very distinguished persons, as we have heard already. We have from Mizoram University, Dr. Silal Engzama, whom we all may know and who is known by his nickname, Dr. Tea. We welcome you to this webinar, and we'd like to hear a very wonderful presentation from you, and we are ready to inculcate new learning materials from your presentations that we're going to witness. And secondly, we have Mr. Arti Silal Remruata, a faculty of HATIM, Faculty of Social Work Department at HATIM. So I'd like to welcome you, Sir Arti Sia, that is how we call him. And we also hope to learn new and various new things from you. And we are looking forward to improving in our academics, in our research works through your presentation. At this time, I welcome both of you in a very special manner to this webinar. And I'd like to welcome all in the panelists and those of our colleagues that are present here, and all the other participants. Those are from our students. I'd like to welcome all of you, and I'd like to urge you to not to try not to miss out any of the presentations, any of the events that are going on in this webinar. And I'm pleased to welcome you all. And with this, I'd like to end my speech, and I'd like to wish you all a very successful webinar on the topic, the basics of SPSS in social sciences. Thank you.
Thank you, sir. Your support is always a blessing for us. Now I request our respected head, Department of Social Work, Mr. Rosang Lianakiente, to convey keynote address.
Thank you, Chairman. Once again, good morning, everyone. Respected principal, resource persons, students of our college and other colleges, scholar and colleague. First of all, I would like to thank to organizing secretaries and coordinator for inviting me to address the keynote of this state level webinar on the basic of statistical package for social sciences, which is commonly known as SPSS. So let me start with a brief introduction to SPSS. SPSS is a short form for statistical package for the social sciences. So this day, SPSS is a widely used program for statistical analysis in social science. And it has a long history. The first version was released in 1968 by the 3 PhD scholars of University of Stanford, and it was later acquired by New York-based company IBM back in 2009. Since then, its name IBM SPSS. So SPSS is a comprehensive and powerful tool for data management and statistical analysis. Just let me highlight the 2 main features of statistics. Number 1 is descriptive statistics, such as chart, features, frequencies, measure of central tendency, dispersion. And the second one is statistical estimation, cluster and factor analysis, correlation, etc. SPSS is widely adopted by most researchers and research groups since it performs both simple and complex statistical analysis. Apart from this statistical package has many benefits. Let me highlight only 6 points of the beneficial point. Number 1 is a broad set of statistical instruments. And second is, it is easy statistical analysis. Number 2, we have integrations with open source. And next, reliable and fast answers. And also it has a large number of statistical tests and wide variety of languages. So even if there are several software available in the market these days, SPSS is more preferable than other software since SPSS is a user-friendly software and easy to use for the beginner as well. So why we should learn statistical package? There's so many reasons, and one thing that is very important, having a good knowledge and learning statistical package for research work is now of more important than ever before, since the Parliament of India recently passed NEP, which is known as National Education Policy or New Education Policy, which is soon to be implemented. And this policy make research is a mandatory component in undergraduate level. So therefore, prior training, learning statistical package like today with Minor is vital for teaching faculty and student in the college. And for that reason, our program for today is very relevant. This webinar is meant to give the participant the basic knowledge of data analysis using SPSS. And this time, as our respected principal already mentioned, we have Dr. Silal Engzama, Assistant Professor in the Department of Social Work, Mizoram University, and Mr. R.T. Silal Remruata, who is also a coordinator of this webinar, will give us a lecture on descriptive statistics in SPSS, data entry and processing, Kuiper test, and t-test. So I strongly believe that this event will encourage all of us and enrich our research or project work, especially the youngster among the participants, to publish their work in the state, national, and international level. And lastly, I hope this webinar is a grand successful with your active participation. Thank you so much. That's all from my end. Thank you.
Thank you, sir. Your support for this program is enormous, and we thank you yet again, sir. Now we shall turn our attention to our experts. Dear participants, please be patient and stay with us throughout this program. So without further ado, I now invite our first speaker, Dr. Silal Engzama. His session will cover data entry and processing and descriptive statistics in SPSS. Teachers and students, please do enjoy the freedom to drop questions in the Q&A chat box, and our experts will get to you in course of their lectures. Sir, please take your time.
Mr. Chairman, I'd like to a session with greetings to the principal of ATIM and his colleagues and the organizing members of this seminar. I'd like to begin by giving a vote of thanks because it is such an honor for me to be a resource person in this program. Although I found myself very small to be a part of this program, but anyway, I will try my best so that all the participants will be and benefit from this program. And good morning, everyone, to all the participants. As our keynote address focused most of the concepts that we need to understand about SPSS. So I will not discuss much about SPSS, but let me begin with some few concepts. A small request to the host, if you can enable the screen sharing from my side. I cannot share my screen. If you can enable me to share screen. if the host can enable me to share my screen. I cannot share my slide. Yes, oh, all right, thank you. All right. SPSS was developed in 1968 only for social science subject, normally like psychology, sociology, and health human services. It was widely used in the social science stream. And when SPSS was purchased by IBM in 2009, it people began to use SPSS in different variety of fields, and it not only social science uh, subject, but in the field of commerce and other sciences, those who need to test their complicated data with uh, sophisticated statistical tools. So now it is usually known as IBM SPSS statistics. So it is a statistical package to analyze quantitative data and mainly using different statistical tools. And uh, not only quantitative data, but also even qualitative data were also quantified, and it can be tested using this SPSS. And we have to remember before looking deep into SPSS, we have to know that it is a tool, and we have to understand uh, statistical tools and analysis in order to use SPSS effectively, because SPSS is a statistical tool. It cannot generate on its own. So we have the person who operates SPSS needs to understand these statistical tools and analysis. So while we say that this SPSS is a great tool to understand and to analyze data, in the meantime, too much dependence on SPSS may hamper the growth of understanding of statistics among the students. So we have to use it carefully. Otherwise, it may create dependency and analysis of data without actually understanding why and how to do it. So let's go deep into SPSS. If you open SPSS software, the two things that will be visible is variable view and data view. So let me explain it like this, and then we will look at the page, the software more closely. So in the variable view, variables are presented in a row, and the column shows the properties, and you can give name to the variable, but in the meantime you need to avoid space, special characters, and you cannot start with numbers while giving names to variable. So this variable name, label, values, and measures are the only four important properties that I will be explaining today. So if you look at this is uh, SPSS, IBM SPSS Statistics version 21 look like. I'm using 21, so many new versions have come up already, but as this is one of the version that I've been using, so I'm more comfortable with this version. So in the top, in the bottom left corner, you will be seeing data view and variable view. So data view and variable view. So I'm going to talk about first variable view. So if you look at the first column, it is labeled as name. So this name you can give a variable name. For example, you can give gender. And this gender, your data entry type will be numeric. If you are going to enter it by number, then you can use numbers here. So, and if you don't enter into numeric, you can click it and then you can enter in numeric. Sometimes you can enter in dollar, currency, or string. So if you select this string, you're going to enter it with words. So, but in data entry, to save time and energy, it's usually coded and entered as numeric. So this width and decimal, we don't need to explain because this is just the width of the column. So if you, it's set as 8. So this, if you look at data.
Sir, may I interrupt, please? The screen is not visible, sir.
Ask him to close the PPT completely.
So you may close the PPT completely
And share screen again.
and share the screen again.
You see the screen now.
Okay, sir, it's visible. Thank you, sir.
In variable view, the column here, it's like a spreadsheet. The row will represent variables. For example, I'm giving a name to gender. And as I have said, you cannot give space to the name of variable because it will, it's not allowed. It's illegal character. So if you want to write gender of respondent, then you have to put underscore in order to name like this. So gender is the first variable and the type is numeric. You can enter into numeric or date or currency or string. String means you enter the data in words. So here you will find label. This is where you describe the name of variable because the name of variable may not be able, we cannot give a very long name to the variable. That's why here in the label, we will write gender of respondents. So this is how your the output will look like, gender of respondents. So here, if you look at the second column in the right, measure. This is where I will be explaining afterwards. These are the kind of data that you will be needing to understand. For example, gender is what kind of data? Here in SPSS, there are 3 different kinds of data: scale, ordinal, and nominal. So gender falls within nominal data, so we will select nominal. And just like this, SPSS does not have any thinking on its own. That's why we are going to insert the, I call it brain. Ang ay tuwa na beraka I kandalo doon sa values sila ni taa. So if you look at values, you will click it, and then this is how the SPSS is going to think. For example, if you enter the data, value 1 as a female and 2 as a male, and the value of 1 and 2 does not have any meaning, just a coding. So if you enter like this, for example, see, the SPSS will read all the number one in as female and number two as male. So if we go to data view, then we are going to, for example, let me enter data. And if we enter here, then we have to enter as 1 or 2. And SPSS is going to read, for example, let me enter some 10%. So here, this is how I enter the code. And in variable view, the values are 1 is female and 2 is male. So if we go to analyze, and then if we see how many males and females, then for example, then this is how statistics will look like afterwards. All right, so this is how you enter the variable view. There is a variable view, and in the meantime, if you go to data view, this is where data are entered. It is like a spreadsheet. And opposite to variable view, the column will represent variables, and the row represent number of observation. So this is like, for example, the row represent respondents. So the one respondent information will be presented in a row. So you can enter directly in SPSS, or you can copy it from Excel spreadsheet. For example, let me copy it from Excel. Let me share another screen. All right, see, this is what I have imported from spreadsheet. I can directly copy and then copy paste here in this data view. So after this, I will edit the variable view. For example, here we have height and weight, age and gender. So if you look at data view, height is presented in a column, and weight is presented in a column, and age is presented in a column, and gender is presented in a column. So in the variable view, if we go to variable view again, it is presented in a row. So the label will define height is in feet, and weight is in kg, and age is in years, and gender is gender. So this is how you enter data. Coming back to so you have to excuse me because I have to share the screen one by one. So if you look at the slide again, we have data view, you can enter data on SPSS directly, or you can copy and paste from an Excel spreadsheet, or you can import from Excel spreadsheet. Before that, before entering data, we have to know the scales of measurement of data. We have, in statistics, we have 4 classification of data, that is nominal, ordinal, interval, and ratio. But in SPSS, data are classified into 3 only, because interval and ratio are amalgamated into in the form of scale. So what is a nominal data? What is a nominal data? A nominal data is shows what kind and what is the nature of classification of observation. For example, we can give it as gender, types of family, types of cars. So there is just a classification, and the classification does not hold so much value. So this kind of data are known as nominal data. In the meantime, we have ordinal data. Ordinal data are categorical, and the order, there is an order in the data. For example, we can say that small, medium, and large. So these are the classification does have a value, and the order matters, and there is a difference between the orders in terms of values. Even Likert scale is also among the ordinal data, because Likert scale have certain order in the or values in the data, and the interval and ratio data are amalgamated in the form of scale in SPSS. I cannot talk about other software, but in SPSS, interval and ratio data are put in the form of scale. For example, scale measures how much exact nge ti ka asota. Tin interval a chuan in exact nge kg ni chuan kg exact nge, height ni chuan san zong exact nge, weight ni chuan what is the weight. And in terms of ratio, there is the interval variables are shown. Pakhat zela kg exact nge. So this kind of data are known as scale in SPSS. So we have to understand that these are the kinds of data before entering in SPSS. So let's go to analyze. After entering those data, these are the descriptive. My topic is descriptive statistics and correlation. So I will be talking about descriptive analysis. Kanti tumbera chu SPSS a chuan data analyze ania. Chumi analyze to chuanin chi frang ni china kan head of department kan soi to a khang ho zinga kan descriptive statistics de ki karon soi do na. Chu ta chuan descriptive statistics can teach on what set of numbers look like, what are the frequency count, what are the measure of central tendency, and what are the variability. Hang over here descriptive statistics in a form big ten here. Descriptive statistics teach on it describe the situation through numbers or through highlighting the difference or highlighting the collective measures. So, descriptive statistics are yan karon so ituro to frequencies, percentage, cross-tabulation, mean and standard deviation le explore option how big heng panga big hi karon so idon ani. So if we go back to statistics again, so if you see this SPSS variable view, so I enter, this is an already entered data. So I'm not going to enter here to save time. And for example, this is size of family, and the next one is uh, classification of size of family, and gender of respondents, and educational qualification. These are the variables that I have entered. So we are going to see the frequency and percentages. So to analyze, there is in the top, on top of the variable view, we will see this option: file, edit, view, data, transform, and analyze. So we will be using this analyze option. And if you click analyze option, options will pop up. And here in this, there are varieties of analysis available, and among them is descriptive statistics. So if you put your cursor in descriptive statistics, and another option will pop up, and that is frequencies, descriptive, explore, crosstab, and other analysis. So today we will be focusing on frequencies, descriptive, explore, and crosstab. So first, let me calculate frequencies. For example, here, I'm going to calculate classification of size of family. So here in this option, we will click whatever variable we like to analyze, and then we will add in the variable. And since statistics have done for us, we will click OK. So in the output, we will find what kind of products are available. Say, let me go to screen sharing again. So this is the product, the output that you have seen in as as I have just clicked just now. So if you look at here, the first table shows gender of respondents. So the gender of respondents, before we classified it as male and female. Male and female. So here it shows there are 26 female and 34 male. See, this data is data collected by one of the students, the current students, Gracie Rinfelli, on her project in study of stress among youth, stress and coping styles among youth. So I'm borrowing her data. So there are 26 female and 34 male, and the percentage shows that there are 43% female and 56.7 are male. So if you look at the outcome, I think I don't need to explain so much about frequency and percentages. And the below table shows that educational qualification, the educational qualification table shows that most of the respondents are between HSLC class 10 and HSSLC. So majority are in HSSLC. So, so this is how the data look like. So the classification of size of family, let me go back to before, wait, okay. Let me go back to one of the slides. Here, uh, the second variable is classification of the size of family. So in the values, we put small, medium, and large. So we enter the data as small, medium, and large. So this scale, we are using standard scale. Small maybe 1 to 3 members, medium maybe 3 to 5, and large maybe above 5, or whatever standard deviation that standard scale that we can find. So we can use that one. So this data, if you look at the screen here, in the classification of size of family, in the classification of size of family, so we find small families are 5%, and medium family are 71%, and large family are 23%. And this data shows that majority of the respondents are, majority of the family are medium-sized family. So this is how you are going to calculate frequencies and percentages. So this is how you are going to analyze data using frequency and percentages. So going next to the please bear with me. I have to end the screen sharing and then begin another again. If you look at the same data again, now I'm going to talk about a cross-tabulation. Cross-tabulation, before we put only one variable in one table. Now I'm going to insert two variables in one table. So that is what we call cross-tabulation. So two variables are going to be analyzed using one table, and we will go to analyze sayang kan kalanga ta chon descriptive statistics ti khalo lenga so ta chon cross tab ti khalo donani cross tabulation. So we will choose this cross tabulation, and for example, so I want to put two variables, that is gender, if I want to put as a row or column. For example, if I want to put gender as column and educational qualification as rows. So I'm going to put this two variables in one table. So for example, so through cross tabs, so then I click OK. So this shows. So the statistics will show that, for example, wait, I think it's better if we show PowerPoint slide, yes. Can you see the slide? So here, this is the output from cross tabulation. So if you see this one, so the row will represent educational qualification, and another variable is the column. The column will show gender of the respondents. So these two variables are put together, and this is what we call cross-tabulation. So here in the data, we can see that among the metric class 10 students, female are more than male. In higher secondary school, male are more than female. So this from this table we can conclude that male are more among the higher educational qualification. Men possess more educational qualification than female. So this is what we call cross-tabulation. And then if we go back to this slide, let me repeat. For example, you go to analyze, descriptive statistics, and crosstab. And using this one, you can analyze any 2 or 3 variables, even 2 or 3 variables, you can cross-tabulate and put different 2 or 3 variables into one table. So this is what cross-tabulation will look like. So the next slide, in the next analysis, I want to talk about mean and standard deviation. So this is how the result will look like. In order to get this result, mean and standard deviation, first let's look at the statistical data. For example, here this data is borrowed from Gracie Rinfelli, and here in the variable you will find coping strategies of coping style of youth in stress, how they cope with stress. There are 6 coping style here. So the first coping style is I take exercise. The second one is I indulge in sports. The third one is I manage my own stress. The fourth one is I read self-help books. I resort to praying. And the sixth one is I write out my feelings. So all these are, see, if you look at in the values, it is a Likert scale. 0 represent never, 1 represent rarely, 2 is sometimes, 3 is often, 4 is always. So the respondents rate their feeling and their opinion as never, rarely, sometimes, often, and always. So it is like a 5-point scale. And all these are, as we have said, it's a ordinal data. So these 6 variables, let me take a mean in order to understand. So if you go to analyze, then descriptive statistics, then you go to descriptives. Here you will find mean and median. So for example, this is how you press descriptive will look like. So select whatever mean you want to calculate. For example, I want to calculate this uh, six coping style. Then I add into variables, and then I click OK. So let me go back to the product again. So if you look at this slide, you will find that this is the product of what I have just clicked. I put it in a slide so that I have the chance to annotate. So we have here, I take exercise. So I take exercise, and then N shows that the number of respondents. And this data is taken from, as I have said, a study made by Gracie Rosenfeld. And the minimum score is 1, and the maximum score is 4. So the mean shows that it's 1.6. So if you go back to the scale, then you will find 1, 2, 3, 4. So the scale falls between 1 and 2, and it is more towards 2. That's why we can conclude that most of the respondents take exercise, and sometimes take their exercise to cope with their stress. And in this column, you will find the mean. And this mean should be calculated from this mean is calculated from the values that you entered. For example, let me go back again. Here, if you look at this variable view, here in the values column, you enter this data. 0 is never, 1 is rarely, 2 is sometimes, and 3 is often, and 4 is always. So depending on these values, your analysis, your mean, your calculated mean will mean something. For example, Nichina kan result ka 1.6 ania. 1.6 ka 1 le 2 ka ra yan oma. 2 lampang na iso ka bangin, sometimes sa yan fall tani. Je chu iu te hianin, thalai te hianin, unstressed achangin exercise and latry. Ika result karon nita. That is the power of mean, calculating mean. So let's go back to this one. See the mean. If you see the mean, indulge in sports sometimes, and 2.6 is this one. It's always. For example, the youth manage their own stress. They don't go to professionals. They don't seek help others. They always try to manage their own stress. Most of the time they succeed, and very few they are unsuccessful, and after that they go to professionals and other help. So likewise, self-help group is also sometimes. They don't always read self-help group. It's sometimes. And praying is when they have stress, they always pray. And I write out my feelings. This is about expressing. They rarely write out their feelings. So this is how means are calculated and analyzed. In the next column, we have standard deviation. So standard deviation here, if you look at the standard deviation, it's a set of numbers, but if you know how to analyze standard deviation, then, for example, it can be seen like this. Yes, here. Standard deviation is how spread out the data is from average. How is the different observation different from the calculated average? So that is what we call standard deviation. And in the meantime, we have standard error, and I will be explaining this standard error afterwards. And so if you go to this one again, no. Yes, here, if you go to this output again, the standard deviation is 0.79 here. For example, 0.79. I take exercise is the standard deviation is 0.79. It's less than 1. So it means that more than 2/3 of the respondents deviate from the mean, that is 1.6, in a less than 0.7, 0.8. It's not even 1. Giờ chú khi mình mean trong kia nên respondents mun thu mất hay là mun nệ chuang kha 0.7, 0.8 chú mà kia nên debate này khi mình pon là mà kia nên ăn cal phăng lộ giờ chú ami này hi ăn trộm pui travel này thì nani. That's why even the mean is very reliable. I mean mean kan soi don hian a reliable and thì nani. The observation tam tak hian in an trộm pui de ubet. I mean an trộm pui a chia 1.6 vanilo ma sela 1.6 sa trang hian 0.8 aya tam hi tam lama mo atlem lamina mo an kal lo kina anita ni chu. So the same is applied to the other standard deviation. So we can say that the mean, Elia, our conclusion, our mean is very valid in terms of taking the average. So the next one, hian kakal porporanga you can ask question in the Q&A box. Then afterwards, I'm going to summarize it. The next one is, for example, here, if you look at this one, and if you go to analyze again, the next option that we have is this is there are so many data that we can say it, but this explore is usually used to see the nature of data to to what extent we can include the analysis and what kind of analysis tools and techniques can be applied. In order to do that, sometimes we first go to explore and then see the nature of data. And in the meantime, this explore option will tell us, even as like a finished output, it also can tell us what is the nature of data. For example, if I look at size of family, classification of size of family, educational qualification, based on here the dependent list. These are the analysis that we need, and based on gender. So we will put in below in the factor list. So this is where the factor will determine size of family, classification of family, educational qualification, gender. Angin kan classify nga male female here sangin can analyze down dinani. So if we click OK, then let me share the output. So this is the output. Tahian output tahian alone. See, this is what we call explore. Size of family here. Size of family here, it is analyzed using female gender, male female in can differentiate. Like female whole zone statistics it is shown here, and male statistics so so headline here in standard error I mean standard error so it does not talk about error. Standard error means the standard deviation of female, like female big le avoidable comb, male female bell comb, standard deviation at female chow, standard deviation at naka along it atlen tell standard error atlen and we can call it as the standard deviation of female is not deviating from the whole population standard deviation. Female population here come standard deviation as a by undetermined look to low tinani. For example, standard deviation ni alo san piawa as a by and long home and it's one female here extreme item oma here data extreme can mutate along too. So this is here you can find for example median variance standard deviation range interval range skewness kurtosis kan tiang zong ka through explore mang hianin all some takin tiyan mo ya. So first you need to understand this statistical analysis. Our focus is mainly on frequency and percentage, cross-tabulation, explore mean standard deviation. So I'm just telling you that there is an option where we can analyze data through explore khan kan soi ta nuala here a Q&A Q&A ron lu te hi kachang hal donang emma what tools would be best used to analyze Likert scale data? Likert scale whether it is a small or large sample size, it is ordinal data. Ordinal data ani bangin whatever enge engtin kan soyang atu lakha enge kan zon chu atur ti azir khan mean te zon chu te ya nakina karon soidon thawa correlation te ni chuan we have to use a different for example spearmint te mangai ka ni chu Pearson char kha man me theilawa a data ina a support le amil pui ang tool sakha than to kha om zela chu bang chonin the question is very vast, so I cannot answer all your questions. So it depends on the data. For a large sample size, we can use, if we know that it is an ordinal data, then we can select data that are possible with what we call ordinal data that supports analysis of ordinal data. So the next, if we go to the next slide, I want to show you what is a correlation. So first, let me go to correlation. So correlation is a statistical analysis that shows the relationship between two variables. Which is nakan soito ang khan variable pani ka an in a relationship an name in zom nan name an in mong to name e ka zon chuana ka correlation ania. So it ranges between -1 and +1 score ka. There is correlationship om tinia. 1 kai it shows perfect correlation. So the higher it goes towards 1, then it shows the correlation. So there are 3 analyses in correlation. Nichina zona ronzo tu pokani zo katuna hena tangkai don chia. Correlation hi chit huma oma amaro chu amandan hi chin ni topina chen theya pakhat chu Pearson correlation tinia adang le chu spearmint le Kendall stau tini Pearson hi nominal data mangbeka. For example, nominal data kanti chu ni china kan soi classification of respondents kanti gender tiang chi te antenna educational qualification kan tiang chi te just selection of colors kan tiang chi te educational occupation types of occupation kan tiang chi khang nominal data ho relate a correlation zomnan khan man ania. And in the meantime, scale ho interval ratio ho correlation zomnan pohan Pearson sar hi an mangtlang pui zoka tuta chon nominal data le scale data tan hian Pearson's R hi an mang tinani. For example, age kan ti te. What is the relationship between age and gender kan tiang chi te. Age to scale ania interval data nia. Gender to nominal data ni. Chumi panni correlation zomnan chuan correlation zomnan chuan Pearson's R hi an mang chinani. it's a measurement of the strength of linear relationship, and the Pearson's R he a measurement of linear relationship ani it's a one-way relationship. For example, if I test the relationship between height and weight. For example, height here and weight a predict them the correlation ka kan zon chuan nakina data te po kan ho lenga height kanin weight ka determine the ka one way chin the ayan ni to Pearson's ara chuan the height kan weight ka predict them sang hi an written the ka kan zon do chuan we are going to use Pearson's R because they are both nominal and scale data, and it is one-way relationship, linear relationship. On the other hand, we have Spearman and Kendall-Stowe. Spearman like Kendall-Stowe itu adu so katantaya. Masela the data should be categorical or ordinal. Categorical mo ordinal data yanin Spearman kan mangitina question sinaran soyang khan data, for example, if it is ordinal data Likert scale kan tiang chi ni china example kan so ang chi atakan Spearman mo Kendall-Stowe mo manturan achan chu they are categorical ordinal, and in the meantime there is monotonic relationship. For example, if we go back to data here, hemi data here nakina kanen ho thobanga. I take exercise, indulge in sports, I manage my own stress. It is monotonic ani wangin take exercise and apong big chuang lo danga hi anin hong ton ani they read self-help group. The one who reads self-help group also take exercise. The one who take exercise also read self-help group. So it is not one way. It is in both direction. The relationship is in both relation. Ani kalaika kan endon ani. So let's look at correlation in SPSS. SPSS akanin at takhan wen letayla here. So this is data view. A data here in Nula. In the column we have height and weight. Height weight he correlation height 2 it's a scale. At a variable view of let one height weight 2 they are both measure in one they are both scale and we can use Pearson's R. So let me analyze then correlate. This is correlate, and you go to bivariate. Then if you want to find out the relationship between height and weight, height he enter weight he enter lenga. Then here in the lower we have Pearson, Kendall-Stowe, Spearman, Santoro, he Pearson, he can then two-tailed and one-tailed lie upon his trying to say test of significance here. Two-tailed, one-tailed means one-tailed that one when height increase, weight also increase. Teacher one to can move one-tailed tani a direction a car kong khatse na kala. The other one is two-tailed and it's one height increase one weight here increase them teacher win weight here reduce them height here increase in weight increase them height increase in weight here decrease them height here a decrease in weight here increase near a decrease. Like two tails on a cover tani, whether it's a two direction. And here there is option flag significant correlation. So a significant relationship omaka minron trail don't tani. See, I put okay, and then let's look at the results. Right, let's look at the results. So here, in the result, this is how the tables will look like in the output. Output katihianin aron lang tani. So, age in years, gender, height, weight, it is 0.0. So if you look at the numbers here, if you look at the numbers here, there are two star mark correlation. For example, if you look at this one, gender le height correlation. So how do we understand the correlation? How there is gender and height le gender here in Zoom Nande. For example, this is positive. A positive abangin male car can enter the khan, one car female and two car male and bangin. Two car tamzo bangin, male khan tamzo bangin. Here we can say that men are taller. Correlation kaumtane. So gender le height ka, there is a significant correlationship. And we can claim that male are taller than women. So helaya star marki and letayla helaya star marki. There are two stars. It means that 0.01 level and a significant. If you look at this one, if you look at this one, height in feet, weight in cases they intersect here. An intersect of we can say that height and weight are having a correlation. Height asanin weight po sang don tinani. Kanda talaga yanin when the height increases, the weight also increases. Pearson's R and bangin, it's only one direction. Height in a weight increase, weight in height increase the candidate halo. Because it is Pearson's R, and these two are having a relationship. So height will determine weight. When the height increases, there is a increase in weight. A correlation in statistical analysis. We can further run another statistical analysis, that is what we call regression analysis. To height in chikadzela weight anxiety and increase to regression analysis and can test but our topic do not include this one, so I will leave it for your thinking. And this is what we call correlation through Pearson's R, Pearson correlation, and the correlation. Another one is just a moment. Yes, this one. Here, in this statistical set, we have ordinal data. Helamayanin, a coping style 1 to 6 here. A coping style 1 to 6 here. We have Likert scale, mga te anita. Say, 0 is never, 1 is rarely, 2 is sometimes, 3 is often, 4 is always. So these are all ordinal data. Ordinal data nivangin, we are going to use Spearman or Kendall's Tau. So we will go to analyze, then correlation and bivariate. Bivariate, and then say, like a coping style ho kan ke mani na I correlation kan zon du zong zong kan select nga one we will include in the variable, and here we have Pearson Kendall style le Spearman oma eta yan Spearman he can click nga because the data is nominal. It is ordinal, I'm sorry. It is ordinal, that's why we are using Spearman. And one tail nilawin, two tail kan mga, then we are going to click OK. So, adata, saka so let me slide maker. Then if you look at the slide, this is what you are going to get. Tuna Spearman correlation ka Spearman kan man ka chuan Spearman correlation coefficient hi hian alo lang ta ni china kan soyang khan it is monotonic relationship kan ti ha. There is a two-way relationship. They impact each other. It is not only one way. They impact each other and they have relationship with each other. So if you look at the data carefully, you will find that there are some asterisk mark. For example, here, here, and here. See, if you look at this one, we will see where they intersect. For example, here, indulge in sports intersect with I take exercise. So these two intersect. That means that it is significant in 0.01 level. That means that people who take exercise also indulge in sports. So I think this is something that we can guess it from our understanding also. People who take exercise will indulge in sports. But we need a statistical proof. So this is where you prove that people who take exercise also indulge in sports. So, so if we look at the next one, this I manage my own stress. See, I manage my own stress is having correlationship with I take exercise. See, this is significant in 0.05 level. If you look at this one, we can say that people who wants to manage their own stress take exercise. So the story here is that people, the youth who want to manage their own stress, try to manage their stress by taking exercise. So this is how you're going to interpret the data. And so if you look at another data again, here, another one is that still here is I read self-help group books. I read self-help books and indulge in sports, have relationship again. If you look at this one, if you see this one, you can say that people who read self-help books also indulge in sports. So the youth try to manage their own stress. They try to manage their own stress by sports and reading books. So they tried on their personal efforts to manage their stress. All right. So if you look at the other data again, here, let me erase the previous one. All right. So here, say this one also have a positive correlation. Those who read self-help group, self-help books also write out their feelings. So it may be the effect of self-help books that tell them to write out their feelings. So we need to see further into the qualitative understanding of this by saying that people who read books also write out their feelings. So there is a correlationship. So this is how you get the data and you analyze the data in correlationship. All right. Let me go back to. I'm going to end. I'm going to end the session. But before ending, let me summarize again. Uh, let me summarize by saying that. Where is it? Yes. Here, sorry. Yes, this one. Statistic package. This statistical package is blank in its beginning. In the beginning, so as a researcher or a statistician or a person who want to extract data, you have to fill in the information and statistics. This statistical package will give you anything that you ask, even if you ask it wrong. Statistical package will still give you the answer, no matter how wrong your questions are. That's why, in order to use SPSS friendly, we need to understand statistics. All right, so here is the data view. You can enter data like this, or you can copy and paste it from. You can copy and paste it from the Excel spreadsheet, or you can import. For example, here you can import data. You can import data from Excel. So there is a possibility that you don't need to copy the whole Excel spreadsheet. You can also import it from Excel file directly. So that makes it easier for, especially for social science researcher and students to use a spreadsheet and make master chart in Excel. So you can easily import it from Excel as they are user friendly. So you are the one who is going to enter a data, and in the variable you are the one who is going to give values. Here in the values you are the one who is going to value, based on your values you are going to the SPSS is going to analyze data for you. So enge amma SPSS amma i sri pui khoi tu thei kan tiang i tu tho lo tho thei kan tiang chi yang kha an mania ti thei kha ni lo ba i statistical analysis hi ki manin a basic ta la kha kan lo fiat ve ngai ani so mi ti tu chuanin only after that we can utilize the enge SPSS a that na kha I kan lamang chuak zo tak tak don lo ti na ani tu bang chuanin even today's lecture also is only like a tip of an iceberg. So I hope that this lecture will give you some insights and uh, some knowledge, and if you get less information also, like at least enthusiasm to use statistical package SPSS in your research, because uh, this SPSS and statistical analysis will improve the quality of your research findings. It will improve the quality of your research output and your whatever you claim as your findings. So it's going to standardize your conclusion, your summary findings, and whatever you claim that you have proved in your research. So I hope this lecture will uh, I hope this lecture will give enthusiasm to everyone. And if you have any doubt, you can drop in the Q&A box. And if beyond this, if you have any doubt, you are free to contact me personally, so that if I have any thing that I can share with you, any information that I can share with you, I'm happy to share with you. Thank you so much.
Thank you, Dr. Tea. It was an excellent and excellent informative session. So it is now time to call our next speaker, Mr. RDC Larambruata. This topic is likely to be, again, more of the practical part. So, dear participants, we request you to freshen up yourselves, stay alert, and join us throughout the program. This topic will cover chi-square and t-test. Mr. RTC, please take your time.
Thank you, Mr. Chairman, and hello, dear participants. It has been a great pleasure to speak with you about SPSS, chi-square and t-test in particular. I would like to express my sincere gratitude to our respected principal, Mr. Bonsang Avansong, and also to the organizing committee for inviting me to speak on this webinar. And I personally find it very interesting, yet very challenging at the same time. So moving on to the topic assigned to me, we'll discuss about chi-square and t-test. Can I request the host with, sir, is my voice audible? Hello?
Yes, it's audible.
Okay,
But
thank
it's
you.
a little bit near.
Okay. Is it clear like that?
Yes, yes, yes.
Okay, thank you. Now I will share my screen. Our topic for today is chi-square and t-test. The first thing I would like to talk about these two tests is that chi-square belongs to non-parametric test and t-test belong to parametric test. And both of them are used to test the hypothesis. Both the tests are used to test the hypothesis. Or hypothesis test non confunctory. Chuanin hypothesis test to chuanin first, it is obviously enough we need to have hypothesis. Draw. In order to explain it, we will go to chi-square. Now let us try to understand what is chi-square. Chi-square test. This test is also called chi-square test for independence, Pearson's chi-square test, or chi-square test of association. Oh, the kind of so don't get confused. It is used to discover if there is a difference between two categorical variables. Conmansi resource person can categorical continuous variables, nominal, ordinal, scale, detail, aron soipian. However, since those scales are very important, we will briefly repeat those types of data. Okay. Moving on to the assumption of the test. Your two variables should be measured at a nominal or ordinal level. Nominal or ordinal level. There, we might still be confused about what is nominal and what is ordinal. So, let me give you a brief example. Nominal data can be ranked in the things that you can briefly classify into categories. Category in which nominal can be if we look at here, gender the male and female conversion more. Profession pun is surgeon, nurse, dentist, adam community ni for la rural, urban, tribal community di kan ba chen fang hok the da. Khati ngang hau kan chen flok and again we have ordinal scale. Ordinal scale as it is self-explanatory from the name itself. Khang nominal or categorical category how order homogeneity in language ordinal and the most common example will be Likert scale and more. Usually we have highly satisfied, satisfied, dissatisfied, highly dissatisfied. So those are the two types of data we have to consider when we are going to use chi-square test. And what I would like you to know is that chi-square test is used to test the difference between two categorical variables or cutting variables but the categorical kan two gender profession community kan yang si how more cutting ang pahingkar ang danglam na o mementi so we use this particular test. On the other hand, if you want to see whether there is a relationship or maintenance on those, you go for correlation. But if you're looking for the difference, you use chi-square test. Ati ra kan soi to kan hypothesis kan nei ta. Hypothesis we again classify into null hypothesis. Null hypothesis can be to HO angalati. Null hypothesis he can alternate hypothesis HA or H1 in an present tree. So null hypothesis there is no difference between two categorical variables. Hemi te pati current dang lam na no in null hypothesis current form tree dang. In alternate hypothesis there is a difference adang lame abang dollar itu. Kami base contest kan run dollar. And there is no substitute test for chi-square. Chi-square is substitute test of law. Test dang suppose we say t-test, there's always a substitute test. Chi-square is substitute. And the number of classification or category is not fixed. Variable, but for example, we are trying to see the difference between whether there is a difference between gender and profession. Hemi antoya category male, female, surgeon, nurse, dentist, and how he can do that. But he very so and it already lam nelonia. Katakan pathum pun chen shangte, pali pun chen shangte, panga pun chen shangte. It will not affect the result. You are free to classify, make your classification as per your choice. And Kramer's V begitu test kan run pun akan soifia panga. So now I will demonstrate how to run chi-square. Okay, let's open this one. I'm not going to talk about how to enter data. Data enter that is a first session. I can't provide here in the assumptions variables but they can variables these are the two variables, and we are trying to find out whether there is a difference between these two, and these two are classified into male and female. Classifying. And if we want, we can have more classifications, like we enter value 3, and here we put transgender. But for now, we'll go along with this original data. And here the educational qualification is 1 in high school representative, 2 in higher secondary school, 3 in undergraduate, and 4 postgraduate representative. If you want, you can add more categories, or you can discard some of this. A result. And here the measurement, nominal, ordinal, at the assumption satisfied. In that case, we satisfy the assumptions, and now we can run chi-square test. Here I'm going to demonstrate how to run chi-square test and how to interpret the result. So I would like to suggest you to note down these steps. It will help you a lot when you try to run the test on your own. First, we go to analyze. we'll go to analyze. Okay, before that, let me just show you the data view. This is the data that we have. We go to analyze and go to descriptive statistics. Analyze and descriptive statistics. There you have to click cross tabs. Cross tabs, then click right. I will repeat, analyze, descriptive statistics, and cross tabs. Click it. Here we have rows and columns. Row and column. In chi-square test, it does not matter. For now, we'll put gender into rows and educational status into columns. If you want, you can put gender into columns and educational status into rows. It will not affect the result. And we will go to statistics. Go to statistics. Since the reason why we run this particular analysis is we want to find out the chi-square value. So obviously we will click chi-square. Here I strongly suggest you click phi and Kramer's V. Phi and Kramer's V click ulah. You might have a question, why? The answer to that question is chi-square table will tell you whether there is a difference or not. In addition to that, Kramer's V value will tell you the effect size. Is it large? Suppose they are different, the two variables are different. It will tell you whether that difference is large or small. So we'll just click continue and go to cells. Here you can, I will click row for now, and if you want you can click any of this expected column, total, or whatever you want. For now we'll click observed and row, and then just click continue and okay. Here we have 4 tables. The first one is case processing summary, and basically means number of observations, or sometimes we call it sample size. And percentage is 100, and there is no missing data. Now we will go to the cross-tabulation. This cross-tabulation will not tell you the chi-square value, first of all, but it will give you an idea about what you are going to find out in the chi-square table. So that's one in male, female in high school, we have 7 male and 8 female, 6 male and 6 female. Ugia mipa paria nexia pakua, Ugia mipa pakua nexia paria, and we have total 30 more. Here, just from the observation, we can see that there is a slight difference. Dang lam na claim kan su omanin ay am ji lawani ni pale ni chika and education status ni kan chateri. Amaro zu. Now we'll go to the chi-square value. This chi-square table will tell us whether that difference is statistically significant or not. Statistically significant and here in this table we have to observe the first one, Pearson chi-square. We can observe. And then here we have value, degree of freedom, and significant value or p-value. This value in SPSS is computed value. manual calculation in nature in hands of a calculated value in here. And degree of freedom is 3. The formula for this degree of freedom is rho minus 1 into column minus 1. Suppose chi-square table a chart degree of freedom zone is 0.05 a intersectional value and calculated value and to meet in conclusion control. However, using SPSS, we do not have to worry about it because the software already calculated for us here in the significant value or p value. More, a boy more like to pay here with that 0.945. 0.945 there. Heta here remember this. If it is less than 0.05, 0.05 aya at so we reject the null hypothesis and we conclude that there is a difference. Oh, 0.05 aya at so null hypothesis can reject a emite panikara yan danglam na omen in conclusion same shit. Amaro to 0.945 is greater than 0.05. 0.05 I allow the C. Here we fail to reject the null hypothesis. Null hypothesis can reject it also. So our findings or conclusion will be there is no difference between male and female in terms of educational status. Mibale may share hanil danglam na low at that. Now we'll go to symmetric measures. Phi and Kramer's V. It's in a console. Come on. Here, what we have to observe is Kramer's V. The value of Kramer's V can observe at all. Value of Kramer's V at 0 to no association and greater than 0 but smaller than 0.2 weak association so that's one Kramer's V value here it is greater than 0 but it is lesser than 0.2. So the association is weak. Suppose here we find out differently. Suppose here we find out that the significant value is 0.02. 0.02. So that's one we reject the null hypothesis and we conclude that there is a difference. So then, hetami kan adang lamna Kramer's V a value in it. Kami adang lamna anna sami and salo. Is it large or is it small? Kaka minorchip ta anisu. Okay, with that, we are done with chi-square. If there is any questions regarding chi-square, I will take it now. Okay. Now we will move on to the test. We'll set the screen. T-test. In T-test, we have three types of tests, which are one sample t-test, independent t-test, and we have paired t-test. However, in social science research, we hardly use one sample t-test. So we will focus on independent t-test and paired t-test in this session. So what is independent sample t-test? Independent sample t-test compares the means of two independent groups. Group pani shanglak ko kamite ka apakai kinfri. And that comparison is based on mean, average, mean. And we are comparing those two independent groups in order to find out whether there is a difference between those two groups. Oh, ka group pati asang bebete ikar hanin ti dalam nama menti enan dan fakta. Here we have dependent variable and independent variable. Dependent variable is also called test variable, and independent variable is also called grouping variable. Independent sample t-test is commonly used to test the following: difference between the means of two groups, between the means of two interventions or means of two change scores. Here, what is important? Let us look at this note section. Independent sample t-test can only compare the means for two and only two groups. Group party. Suppose you have more than two groups, you cannot run independent t-test, you have to run ANOVA. And the requirement, dependent variable that is continuous. Here we have to go back to the type of scale. Oh. In independent t-test, we will have two variables. The one variable will be categorical in nature, gender, male, female, category. The other variable should be measured at interval or ratio. To do interval or ratio. Interval example on a scale of 1 to 10, rate your level of satisfaction, within which you can enter a number. 1 represents highly dissatisfied and 10 represents highly satisfied. Oh, I think interval. And in ratio, you can have a 0 score. It begins from 0. And during age can be the weight, the salary, they can be measured at ratio. Because let us take salary. I believe that most of the participants today are students. And obviously enough, as a student, you do not have a job right now, which means you do not have salary. So if you do not have salary, your salary is 0. So those score which begins from 0 until how ratio so if we are going to explain it broadly. And SPSS takes interval and ratio together and measure using scale. And here we have the assumptions. Independent samples or independent groups. It means that subject in the first group cannot be in the second group. Suppose we categorize, we compare two groups, male and female. Male section na female because they are confined to their specific groups. And data should be normal and homogeneous. Normality and homogeneity we will run using SPSS. And here we have outliers. There should be no outliers. Outliers, and the outliers basically means extreme cases. Number they fall big to score they big to emo. Lian big to emo ao karin ami aron tidang lamshi na subang. So if there's outliers, we do not run this test. Oh. And there are several rules of thumb. Here, each group should have at least 6 subjects. If your sample size is way too small, suppose, let's say your sample size is only 6. So it is not ideal to run this test. Oh. Balanced design. Same number of subjects in each group. Suppose you try to find out the difference between male and female. So it is strongly recommended that you take equal sample size. So mipa so milak zuan may chepo so. Oh, now we will demonstrate it. Here. Gender variable here we have gender and here we have salary. This gender is categorical in nature and the category are male and female, and it is measured at nominal scale. Oh, nominal at the end. Salary where it is under scale, which means that it is either interval or ratio. And here if we go to the data view, here what we can see is that it ranges from about 29,000 to 64,000. 29,000 to 64,000 cardboard well alone. Let's say, for example, we have 1,000 Sanka kilometers. Oh, at the far big FM that car can be mean around and it's not ideal to run the test. In the same way, if we have 1 lakh, which is much greater than the rest of the observations, a mean score, average score, it is not advisable. It is not advisable to run the test because the findings, your findings using this particular test will not be relevant. And finding a relevant sure you do not satisfy the assumption saying that no outliers. Okay, for now, before running t-test, we have to check normality and homogeneity. Oh. So note down these steps. In order to check normality and homogeneity, we go to analyze. analyze and we go to descriptive statistics and explore analyze descriptive statistics and explore. Now we click it. Here we have gender and salary. Salary, since this is what we are trying to measure, we will put it here. And the classification, the categorical variables, we will put it the factor list. And let's see the statistics. It is 95% confidence interval, which is standard. We will not change this. Go to plots. Here, click normality plot with test and untransform. Normality plot with test le untransform T in click to unit. Because this will tell you, normality plot with test will tell you whether your data is normal or not, and untransformed will tell you whether your data is homogeneous or not. Okay, just click continue. And okay. Here we have case processing and descriptive, but these are not the things that we are looking for. What we are looking for is test of normality and test of homogeneity. Under test of normality, Kolmogorov, Smirnov, and Shapiro-Wilk. These are two most common tests for normality. Here, what we have to observe is the significant value. Significant value he tanpa into ani. And remember this: if this significant value is greater than 0.05, he 0.05 I allen so chuanin your data is normal. 0.05 I added so chuan your data is not normal, so you cannot run the test. And here in both the test, significant value is greater than 0.05 I and D. So we confidently say that our data is normal. And in terms of homogeneity, we have to observe based on mean. Based on mean, you can observe here. This significant value is what we are looking for. And we have the value 0.435, which is greater than 0.05. 0.05 is the standard value. So, which is greater than 0.05, it means that our data is homogeneous. And data are homogeneous. So, we satisfy the assumptions of independent teachers. And this is what I would like to add. For instance, your data is not normal or your data is not homogeneous. In that situation, if you force it, the software will give you results. But that result will not be relevant. There are some people who, among even the scholars, students, and faculty alike, who used to force the test even when the data do not satisfy these assumptions. Basically, what they do is that they want to have results. They want to have conclusions or results based on their data. So they just force the test. Of course, they will have results. The software will produce some result. But since the assumptions are not satisfied, that result is not statistically relevant. In that case, there are times when your data is not normal or homogeneous. But you do not have to worry. Obviously, you cannot run independent t-tests. So in that situation, what you can do is that you can run substitute test for independent t-test, which is Man-Whitney U-test. Man-Whitney U-test the OMA to independent t-test assumption and how he can satisfy the zero chuanin Man-Whitney U-test ha varante. Oh, okay. For now, we will close this. And now we will go to an independent t-test. Here we'll click again analyze. We'll click analyze and compare means. Compare means akan lutang or and click independent sample t-test. What is your test variable? Your test variable is salary. This is what you are trying to test. And you group them by gender. So this will come under grouping variable. And here we have to define groups. Group 1 represent male, 2 represent female. So we'll just type that 1, and 2. Click continue. And let's click options. By default, it is confidence interval is 95%. So we will not change it. And just click OK. This is the result. This is what we are looking for. This table is what we are looking for. And as you can see in this table, the significant value is the same. The t-value is also the same. Whenever you observe independent sample t-test, when you observe the table, always check this living test for equality of variance, the significant value, this one. Check oh, if this value is greater than 0.05, if this value is greater than 0.05, now we have 0.435, which is greater than 0.05, we will observe the first line. But there are times when this value will fall below 0.05. 0.05 aya update về thùng chuanin, you observe the second line at waizo kn2. Centro 0.05 aya alen chuanin at chungzo kin enanga 0.05 aya update chuanin at waizo kin3. And what is important is this significant value. Now we have 0.000. And this does not mean that your analysis is not useful or relevant. The software, SPSS software here, number tell to hard here in 0.000 here what we have to consider is that this value, if it is smaller than 0.05 aya atet chuan, we said that we reject the null hypothesis and we can say that there is a difference. Amaro to 0.05 aya allen chuan we fail to reject the null hypothesis and claim that there is no difference. In this case, our p-value is smaller than 0.05. So the conclusion we can draw from here is that there is a difference between male and female in terms of salary. That is our findings. Oh, now we will close this. And go to paired sample t-test. In paired sample t-test, we compare means from the same individual objects or related groups. Paired sample t-test noya chuanin sample pakhatamo group pakhatamo khami te tanga voi ni data kan la khanin paired sample t-test kan function. Oh, to independent t-test na dang lam na chu oh independent t-test a chuan group sang lak ve ve me b ve te company A company B ti si te khate kan khai khin don khanin independent t-test kan maka paired t-test a chuan group ngai group pakhat atanga poi di data kan la in paired sample t-test kan function. Example tan chuan in hei hilo pangta ila. Suppose we provide you with a questionnaire before the. Suppose we provide you with questionnaire before this training, and again we give you the same questionnaire after this training. Every day we can run paired t-test to see whether there is a difference before and after the training in regards to your knowledge on SPSS. Oh, achang tu daga chu nang mani thawin ni ichang ani chu ta chuan in void the data karon na chi ani chu. Here we will go to the test will demonstrate it. Let me open this file. Before and after, more. Two sets of observations, two sets of data, which are measured at scale, more. Either interval or ratio. Paired t-test chuanin khatiang kha kan run tani. Here we have before faculty. Let's say before SPSS training. Here, let's say after SPSS training. So we can compare the difference of your score before and after this training to see whether there is a difference. Oh, and this is how your data will look like. In order to run the test, we'll go to analyze. Analyze I can look there. Here we'll go to analyze, and okay, before that, you still have to go for normality test. The data normal now empty if I check for something. Oh, Amaro zu data normality test run that independent test can enter to vangin can run to lavanga. But when you actually do run this test, always go for normality test to see whether you satisfy the assumptions. Oh, we'll go to compare means and paired sample t-test. Analyze, compare means and paired sample t-test. Now we'll click it. Here, before SPSS training, we'll put into first variable, and this one will put into the second variable. Here, what you can do is that you can run multiple tests at once. If you have other variables which you'd like to test, you can add it here. You can run multiple tests. Let's see the options. The confidence interval is 95%, which is standard, so we will not change it. And here we'll click OK. Okay, what we are looking for is this table. Hay table here can n2 can bazir to allow it. Here there are mean standard deviation, error, lower, upper, t-value, degree of freedom, and significance level. Cái tiếng nga rồi bằng cách hiện nên áp hồi nghe và observe to they can confuse it. So in this case, we will go to the significant or p-value. Oh, and again, if this value is smaller than 0.05, 0.05 I added. So Suanin, we reject the null hypothesis and go along with the alternate hypothesis. Oh, 0.05 I added. So Suanin, null hypothesis ka control. In this case, we can conclude it in this way that there is a difference before SPSS training and after SPSS training in regards to knowledge on this software or data analysis. Oh, atang lang ka kanto ruta ali two. And there are certain times when you fail to meet the assumption to run this particular test. Paired t-test run because sometimes your data will not be normal. In that situation, you can go for Wilcoxon signed rank test. Wilcoxon signed rank test in Ramthay. Oh, in data normal local paired t-test run you go for Wilcoxon signed rank test. Okay. With that, I will conclude my lecture. And it seems we do not have questions here in this particular topic. So, thank you, everyone.
Thank you, Mr. RTC. I hope we follow the lessons learned today, and with the input of our experts, I believe that the knowledge on SPSS is enriched and that we can do a lot of research in the future for academic growth. So now, without further ado, I would like to invite our esteemed IQSC coordinator, Mr. John Sidardusaka, to propose a vote of thanks.
Okay.
Okay, good afternoon, everyone. I think, like all good things must come to an end, this webinar has to come to an end. So, on behalf of the organizing committee, I would like to take this opportunity to propose a vote of thanks to all those who have directly and indirectly contributed to this state-level webinar on basics of statistical packages for social sciences, organized by the Department of Social Sciences as a social work in collaboration with IQAC Heating. At the outset, I would like to thank our resource person, Dr. C. Lal Engzama. Excuse me, I'm down with a bit of cold. Assistant Professor, Department of Social Work, Mizoram, for his time, first of all, and for the informative session. Sir Thea, we are really thankful to you, and we are really enlightened with your knowledge and presence today. And next, I would like to extend our thanks to our very own sir, RTC Lalem an assistant in the Department of Social Work, 18, for that informative lecture. Again, I would like to thank both of them, both our resource person, and hope that all participants benefit from your contribution in knowledge and skills. Next, I would like to extend our thanks to our principal, our respected principal, for his motivation and his unending support towards the towards this webinar. And also, we cannot forget our vice principal for his enthusiastic support as always. And I would like to thank our Sir Argal Yanzela for chairing this webinar throughout the sessions and making it as interesting as he could. Thank you, Sir Zela, for that. And I also would like to thank our technical team for their support in all the technical aspects that we need to carry out this webinar successfully. Next, I would like to thank our teachers, first of all, apart from our students who have attended this webinar. And at the same time, would like to thank all the participants, teachers and students alike, without whom this webinar cannot be a success. And with this word, I would like to end this webinar and have a good day. Thank you.